let's go ahead and get started. So I've created a file called ifturtle over here to work on our, to teach us about if statements in our turtles. So today we're going to be going over if statements and expressions while reviewing but first we're going to review what we've learned about shapes and the very basic stuff we know about for loops. Again, if you don't feel mastery of the for loops, you'll note that this week's current assignment has nothing to do with for loops, and I say that you don't need for loops to solve any of that. But when we're working with turtles, having for loops makes things very, very, very nice for us, right? So we're going to go ahead and do, and what we're going to do is we're going to first create our turtle. We're going to create Bob, right? And we create a turtle instance by going turtle.turtle. Oh, and by the way, I did post more readings on the Runestone Academy website, so you want to go through those and read those. They have a due date, but it's not like that you don't get if you don't do it by the due date, it's not like it's not going to get, graded. It's just like these are the deadlines that I think you need to be keeping up with in order to keep on top of the work. So let's go ahead and create Bob. He's a turtle, right? We run this and he's microscopic to the people in the back. So we are going to go ahead and say Bob.set shape, or what is it? It's Bob.shape is equal to, right, set the turtle shape to the name. Right, this stuff is very useful, and that's one of the big features of IDEs over like regular text editors, which is that, you get these hints as to what's going on. So Bob.set shape, or shape, we are going to set the shape to be a turtle shape. Bob.shape size is going to be 2, and Bob.pen size is going to be 2. This is all stuff you don't really need. Right? This is just simply changing the look and feel of the turtle. But since I'm doing this on a projector, it makes way more sense for us to do this. We were also talking about color last week, and I'll get to that in a bit, especially with changing colors in for loops, but hey. Okay, so Bob is equal to, so now we can, and remember, we make Bob move by telling him to go backwards and forwards a certain amount of distance. Right here, boom, and there. We can also change his color by saying Bob.color. There's a couple different ways to do color. First, if I say color is equal to red, it makes him red and the line red. White, and then if I say pen color, his outline becomes red and the line becomes red. Why is it important that he's red? Sorry, like, is he red or black? We'll learn about that when we talk about the stamp function, which is another way the turtle can draw things. But for right now, we're just going to deal with this. So I'll just simply say color is red, Bob.forward 100. All right. Now this is, now we can put like a bunch of different colors in here. We could put gray, or we could also put gray, right? So it accepts both spellings of gray. Does this accept it capitalized? It accepts your spellings capitalized. Let's see if it accepts it weirdly capitalized, so it doesn't care. So it simply will be removing capital letters to figure it out, or turning everything to capital letters to figure it out. One or the other. Don't know which one it does, but that's a smart way of doing it. Black is kind of useless there because it's already black. White, also kind of equally useless here because, congratulations, we are, this is my picture of a polar bear in a snowstorm, right? So we've got, so any kind of basic color that you would find in a Crayola packet, right? That you'd expect to maybe find in, in a Crayola package that had 8 crayons in it. Those are the colors you can use. You can specify new colors, and we'll talk a bit how to do that later. But for right now, what we're going to do is play with this for loop again. So what we're going to do right now is we are going to do a for loop. And remember, oh, right, that's cutting off the side. That is annoying that it does that. Okay. For I in range. Actually, I'm going to call this for blah in range because, again, it doesn't really matter what you call it. I is not the magic word. What we're doing is we're creating a variable that will exist throughout the for loop. And if I were to do this, for blah in range 100, whatever goes inside here is going to happen 100 times. If I were to change this to 99, it would happen 99 times. If I were to change it to 50 times, it would happen 50 times. If I were to change it to -1, well, we'll see what happens. So I'm going to go ahead and print out just an exclamation point, just to get the point across, right? And there we can see that 100, if you counted them, this is 100 exclamation points that printed out on the console. See? 100 exclamation points. Okay. On the other hand, if I were to do -1, and instead I'll just simply print out a lot of exclamation points per line, it's not going to run any times because what it's doing is that internally it's going, you want range to 100. I'm going to count up to, but not including 100. So I'm going to go, and I'm going to start at 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, in Python, range of variable is 0, is mathematical notation, includes the 0, doesn't include the end, or starts at 0 inclusive and goes up but does not include the endpoint. And because we're counting the 0, it will run if it's 0 up to and not including 100. Well, 1 through 99 is 99 different numbers. And then the 0 is 100. That brings us 100 different numbers. So this gives us, so this loop will run 100 times. Okay, now let's do something graphically with this. I'm gonna do something rather boring with this, to be honest, which is I'm going to just simply say Bob dot forward 1. This is going to just slowly so he moved very slowly there, right? I'll draw this again. And the reason he moved slowly there is because he was getting 100 individual commands to move 1 pixel forward. So it was executing 1 command at a time to do it. And because of the speed of this, there's a delay, right? Okay. Let's go ahead and maybe do 500, right? See, he's moving very, very slowly as compared to if we asked him to just move all at once, right? Oh yeah, and you can totally go off the edge. That's perfectly fine. This coordinate plane is like all coordinate planes, infinite in size, right? Oh, and useful, right? This is a coordinate plane. So Bob.goto, we'll go into this more later. You can give him x, y coordinates to go to somewhere. That's kind of useful. So if I tell him to go to -500, 500, so that would be -500 on the x-axis and 500 on the y-axis. So after he's moved his 500 spaces over here, he'll go all the way over to here. Let's go ahead and increase this. And you'll see, because it's not in the for loop, he does it in one smooth motion without actually ever turning, right? So that goTo function's pretty nifty. We'll get to it more later. I just wanted to point out this is a coordinate plane. Doesn't require any more knowledge than to know that it's a coordinate plane, because you've been dealing with coordinate planes since you've been subjected to the torture of algebra since God knows when. Just doesn't have the axes labeled at all, right? And also, depending on how you code it, the coordinate plane can be optional. Okay? In the sense that you don't necessarily need to use it. Okay. So let's go ahead and introduce our first if statement. So I'm going to change this variable to something more appropriate, called step. Okay? You can name this whatever you want. Typically we name it I because for two reasons. Often we're going over a collection of items, and collections of items typically have, like lists, have indices or index. And so I for index. When we're going to get over that when we go over lists, and when we go into more detail about strings. But another reason is that often we're dealing with an integer, and so we just simply use I for integer. And also it's just nice and easy, right, to type I, because it's right above the J and the K on your keyboard, you know. So I'm sure that also has something to do with it. I'm going to call it step, though, because that's more indicative. It's the current step the turtle's at. So, so now I'm going to print the turtle is at step, and then we learned, right, we have to do str if we want to combine it, right? So we would turn the step into a string, and do that. And so now now it's important that these are indented. If they're not indented, you're going to have a bad time inside a for loop. That's how Python knows this is something you want to repeat. Print. So I'll put this right here, even though it's like the text is, you know, has no white space between it. It's not indented. Yeah. I'm just trying to mentally answer all the questions and correct all the mistakes that I know that some of you have made. So here, we're seeing it count the turtle as he's going up. The turtle is at step, ba 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 ba. It goes up. Step increments once every time with the for loop. Okay, so first off, let's start at the end. This is out of the for loop. Notice that this did not print until we got outside the for loop. We know it's outside the for loop because it is literally not indented inside of something. Python's really nice like that. Other programming languages, you got to use this notation with curly braces and stuff. Python doesn't care about curly braces, just wants you to properly indent your code because that is much visually easier to see. Python is written under the assumption that code is read more than it is written. Case in point, I wrote this once, you read it 150 times because there's 150 of you. But also when you're coding by yourself, you're going to be reading your code more often than you write it, so the code should be easier. If the choice is between easy to read versus easy to write, it should be easy to read. So now going back to this. So the first thing we do is that we print out the turtle is at step 0, and then Bob steps forward one space. In fact, I'm going to change that just to be Bob. And then Bob is at step 1, and then he moves forward one space. And then he's at step 2, and he moves forward one step. Step automatically increases once each time we go through the for loop, right? So this is a functionality of range. Range produces a range of numbers from 0 up to, but not including, the end, 500. I know it sounds like I'm harping on this, but I know that for loops was where most of the students started to struggle last semester. So I want to make sure that you get it. Okay, and now it increases. Now because this is a value, we get to have some fun. We can have some fun with this. Since this is an integer, we can have fun with it. So let me introduce you to an if statement. I'm going to scare the heck out of you, and then I'm going to go back. Then I'm going to go and explain the if statements in a bit more detail. And then as well as Boolean expressions, and then we'll come back to this. So, if step, so most of the time you don't need an if statement inside a for loop. If statements can be anywhere, but right now it's just inside the for loop. If step is greater than 250, and notice it gets indented as well, bob.color green. Actually, purple is like the opposite on, that's blue. Blue and orange. Those are the opposite colors. That's why movies are saturated with orange and blues these days. Okay. So now, watch what happens. Once we get to step 250, he turns blue and starts drawing blue. So let's go ahead and read this. How does this work? So first off, we're printing out so step is currently 0. We print out the step that we're currently at, and then we ask ourselves with this if statement, if step is greater than 250, change the color to blue. And it does that every time. So even if it's, and then we move forward one space. Mind you, this does it multiple times, right? If we're above 250, like if step is 300, we would have already changed it to blue. It's still going to ask again and change it from blue to blue, but that's a discussion for another time. You can have multiple if statements together. If step is greater than 300, actually, let's go ahead and move this over here. If step is greater than 100, and right now this part is what we call a Boolean expression, and I will be going over that very shortly. Bob dot color red. So we start out orange, and we ask ourselves, hey, is our step above 100? Yes, it is, so become red. Is our step above 250? Okay, become blue. And notice now that he's going all psychedelic. Why is that? Anyone? Yes. It satisfies both conditions. It says, hey, the step's above 100, so become red. The step is above 250, so become blue. And then we draw blue because blue was the last thing we did, right? So I'm going to go over, this is actually a great example I'm going to have to come back to, because right now I want to go over our Boolean expressions. So what I just threw at you is this Boolean expression. This is the key to our if statements. If statements are just make a decision. They essentially, let's see. So let me make a new file. If statements, they look like this, basically. If let's see. So if condition is true, or rather if true, so if this condition is true, we do this. Else, do that, right? The else's are optional, as we'll see, and we'll go into more detail, but if statements basically look like this. If this, else do that. Notice the else is optional. I didn't have a single else here. Right? So now, when I say this is true, I'm talking about basically true and false values. In Python, values have we'll get into the fact that basically all values have what we call a truthiness to them, which is, I believe, actually a Stephen Colbert reference. But we're talking about literal true and false values, which are evaluated with Boolean expressions. So Boolean expressions are named after a mathematician, British guy, I think, George Boole. He did a lot of basically math on binary systems and true-false values. And binary systems match very well to true-false. True-false, 1, 0, high, low voltage. So, and basically all the operations that work there are very easy or are applicable here. So you recognize Boolean expressions, by the way, from algebra. 34 greater than 2, right? Anybody recognize that? Yeah. Now, when we evaluate this, now typically you would evaluate like this equality or try to solve for x, like when is x true or something like this. But here what we're doing is we're asking ourselves, is this true or is this false? Right? 34 is greater than 2. That is definitely true. Right? And so we get true with a capital T. Other programming languages they spell true with a lowercase t. Python spells it with an uppercase t, and if you forget that, you're going to instantly fail the class and get kicked out of the No, I'm kidding. I'm not going to care. So I won't care in the slightest if on the paper you forget to capitalize your t's and f's. So no worries. But other programming languages do use lowercase, and that throws me for a loop every time I walk into my Java class. So if you see me accidentally do true and falses lowercase, that's why, because I'm teaching 2 languages at once. So this is a false statement. 34 is less than 2. We pretty much know all of the, we know the majority of, actually we know all the expressions we plan on using, which is we know how to use greater than. We know how to use less than, right? 34 is greater than 34. Is that true or false? False. What about this? 34 is greater than or equal to 34. True, right? So we have a greater than or equal to, right? Normally you'd write it, as that nice greater than sign with a line under it, right? But you can't find that on your keyboard. So greater than so it's 2 strokes. Similarly, 35 is less than or equal to 70, or 60 rather, because that's what I hit. Right? So we've got a less than or equal to. We can also check to see if 2 numbers are equal. Now you might think, okay, we're going to check if 2 numbers are equals using the equal sign, and you'd be half right. But you'd get, 34 is equal to 56. But it's going to say you can't assign to a literal. Remember, 1 equal sign is the assignment operation, right? That's where we say, let's store this in this variable. But 2 equal signs, that's what we call the equality operator. This checks to see if those 2 values are the same. Okay, you can also use the equal, and you can use that double equals operator on anything. Watch. Hello is equal to world. Are these the same word? No. How about hello equals hello? Those are the same, right? Those are the same string. Yes. You're dead on, because that's exactly what I was going to do next. If I capitalize this, Python cares about your capitalization. There's ways we'll learn about how to handle this, such as you either make everything uppercase or lowercase just temporarily, but it cares about your capitals.
Does it work with variables if you have 2 different variables?
Yes, it does. So if x is equal to hello, and y is equal to a different hello, x equals y, that's true, right? X equals 34, That's false. Hello is not 34. Notice that you can compare, you can do an equality operator on the like on anything to anything else, because you're literally asking, is this the same thing? Yes.
What if you only use one what instead of exact saying is it equal to exact, because the two equal signs are exact. What if you use one equal sign? Would the two hellos match?
If I were to use one equal sign over here, yeah, they'd be the same. They'd be the same. Because, well, if I were to capitalize it, well, here's what's going to happen. So, right, if I'm using one equal sign, that's the assignment operator. So here, y is equal to hello. All right. So we've got x, we've got y. Okay, right? Now if we say x equals y, x, y, they're both the same. Make sense? So now if we were to compare them, they'd be the same because we're doing the assignment operator. Remember, one equal sign says we're going to take what's in here and store it over here. Now, obviously, this equal sign makes sense for comparing two numbers to each other and two words to each other, but certainly you can't use the certainly we can't do this, right? Why is that false? And why is this? A is less than B true. Yes? Yes, it does assign numerical values to A and B. And that is why we're getting them. I'll go into those ASCII values or Unicode values later, but the way it's figuring out which is less than and which is greater than is alphabetical order. If you're coming first alphabetically, you're less. If you're coming after alphabetically, you're more. That's not going to really be on the exam too much. That's just kind of a useful thing to know. When we, I think we're going to eventually do an encryption kind of deal, and that's kind of useful to know that these letters are numbers, and this is kind of our exposure to them, right? It also means that basically that we can sort basically anything we need alphabetically. So now how does this apply to doing if statements? Well, let's go ahead and basically let's go ahead and make a basic if statement, basic thing. Let's go ahead and say, hey, input is equal. Let's go ahead and write a basic function that checks whether or not somebody's passed an exam, right? Please enter your exam score. And we're going to say score is equal to this, and we're going to automatically convert what we put in into an integer, okay? So we're going to tell them to input their exam score. We're going to put in a colon and a space so that they have plenty of space to input that, right? And we're going to store that in a variable, right? Run it. Please enter your exam score. I'm going to say I got a 65 on the exam, right? And it's not going to do anything after that because I didn't tell it to do anything after that. Okay? Now we say, let's go ahead and now using a basic if statement. If score is greater than or equal to 70, so if, right, 70 or above is typically passing in the US. If score is greater than or equal to 70, print score. Let's turn it back into a string. Score plus is a passing grade. Okay, and I'm gonna not put in the if statement the else statement quite yet because just wanna, yes. To comment out a lot of lines? To comment out, excellent question. To comment out a lot of lines, we actually use something that pulls double duty here. So but to do 3 lines at once, use 3 single quotes in a row or triple quotes or double quotes in a row, either one. And then anything between a pair of single quotes or anything between a triplet of quotation marks gets commented out. The computer does actually something weirder, but it's fun, but effectively it comments it out. Notice that it kind of pops up the same color as a string. So anyway, so if score is greater than or equal to 70, print out that's a passing grade, print thank you, come again. Right? So we're going to go ahead and run this. Right? If the score is greater than or equal to 70, we print out that their score is a passing grade. And again, we're just going to wait on the else statement. End of line scanning. Quotation mark. So 65. So we're going to put in 65. So important thing to notice: if score that we put in 65, 65 is not greater than or equal to 70. So the if statement does not execute. Right? It skips over what's inside the if statement because we're only going to run this. We're only going to tell them it's a passing grade if it's a passing grade. Make sense? We're not going to execute this code unless it's that. Print and then print thank you, come again. Right? This is actually an excellent example that I'm going to and this is going to print out thank you, come again, regardless of whether or not we enter a passing grade or not. So let's run this again. Enter your exam score, 75. 75 is a passing grade. Thank you, come again, right? This executes after the if statement. It's outside of the if statement. So once the if statement is done, no matter how it was done, we're going to print out thank you, come again. Okay, so now let's go ahead and add in an else. If the if doesn't execute, the else will by default. There's no check involved for this else statement over here. It will just simply execute otherwise. So we'll go str score plus is not a passing grade. Right? We're going to just play over here, and then eventually we'll get back to our turtles. Okay? Thank you. Come again. So now if we run this, we put in 75. Same thing happens. 75 is a passing exam score. It skips over the else because the if-else statement says, if it's one thing, do this. Otherwise, do the other thing. We did the one thing, so we don't do the other thing. We run this and we say 20, which is a very terrible score. It will say 20 is not a passing grade. So let's go ahead and fix that over here. 20 is not a passing grade. Thank you, come again. Right? So we get this if, so we have this if statement and this else statement over there. And you can have multiple if else's in a program. Thank you. So let's go ahead. And we can actually have multiple ifs, kind of next to each other. So let's go ahead and just use some copy paste magic to do stuff. So I'm going to copy just the if statement over here. Boom, 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 boom. Right? Because let's go ahead and do this. So score is greater than. So if score is equal to 100, right, we'll have a condition for if it's 100, if it's greater than or equal to 90, we'll print out a different message. If we print it out an 80, right, so C, A, C. And yes, if you're thinking ahead, yes, there's a mistake. There's a lot of mistakes in this, but that's okay. The entire point is to illustrate what's going to happen here. Is a B, is an A is do you really need to ask? Right, so there we go. So now we're going to, hold on. Okay, so now if we enter 65, 65 is not a passing grade. Thank you. Right? How kind. But now if I enter, let's say, an A score, 92, it should print out 92 is an A. Well, it does print out 92 as an A. It also prints out 92 as a B, 92 as a C, and thank you. Now, the reason is because these was this what you were going to ask about? Okay, well, what do you want to ask?
How do I exclude something?
How do you...
This kind of falls into that same
Yeah.
category.
So when we construct complicated if statements like this, we have to think about whether or not our conditions are dependent or independent of one another. Interdependent or independent, right? If they depend on each other or they can happen individually. This is individually, right? If this is true, run this. 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 Otherwise, run this, right? These are essential, despite them being next to each other, this is essentially the structure of the program. Independent clause, independent clause, independent clause, and independent but complex clause, right? We've got this. The else is always attached to its closest if statement. There are ways to get around this. For instance, we could change the order up, but the easiest way is to realize these are independent. Now, let me go ahead and show you the messy, bad way to do this, and then I'm going to show you what the actual nice way that does it the exact same way is. So let's say your score is equal to 100. If it is, print out this. Otherwise, if your score is greater than 90, let's print it out as an A. Otherwise, don't copy this down, for the love of God. I mean, just using if-else statements, which is what we know right now, we could do it like this. The score is an 80. And again, do not copy this down. I'll show you the much cleaner and easier way to do this. And it makes way more sense, too. Okay, else. Let's see, boom, boom. Yeah, I think that's right. So let's go with 82. 82 is a B, thank you, so we didn't get the C, right? If 82 is 100, print this out. Sorry, if 82 is 100, print this out. Well, it's not, so otherwise we go inside and start here. If 82 is greater than 90, well, it's not, so we're going to go inside the else statement and go here. If 82 is greater than this, 80, we go inside here and print it out, which we do. And then we skip over the else statement because it's not the other condition. And so we're done. Oh my God, that's ugly and complex looking, right? Okay, so let's not do that. Instead, what we're going to do is use something called the if-else statement. Or in Python, as it's called, is elif, which is just basically making these all interdependent on each other. Which is saying, now with an if-elif else statement, the first thing that is true is the only thing that's going to execute. Okay? The first thing that is true is the only thing that's going to execute. So let's go ahead and run this 82. Let's run this 82 example again. 82. 82 is B. So if 82 is equal to 100, print this out. Well, it's not. So if this is true, run it. Else if this is true, print this out. Else if 82 is greater than 80, greater than or equal to 80, print this out. First thing that executes gets it, and that's it. And so it's done. It's found it. Make sense? So else if is kind of useful if you need to like have multiple options, right? If you have if else, you just have two options. Do A or B. This allows you choice of A, B, C, D, or default, right? If none of these things are true, then the else is going to run. Oh, and we could totally leave out the else, and it could be that nothing runs, right? But with when you've got this if else structure, something is guaranteed to run. Okay. And before I completely forget, I want to just go back for a statement for a second, right? So right now we've been dealing with fairly simple statements. One thing is equal to another thing is greater than or equal to this, another thing is greater than or equal to this. But notice that when I say that, I have this word, or. 80 is greater than, so let's say score is equal to 65 over here. Oh, sorry, let's go with score is equal to 85. Whoops. 85. Score is greater than or equal to 80. That's going to give us true, right? Now let's go ahead and actually split that up in grammatically. Score is greater than 80, or score is is equal to 80. A greater than or equal to is a combination of these two clauses. Score is greater than 80, or score is equal to 80. Now, there are essentially three keywords in Python we can use for logic to make complex and very frustrating if-else statement, Boolean expressions. And, or, and not. Okay? The first is the last is the simplest, which is not. Which just simply modifies the thing in front of it. What is not true? What's false? Excellent. What's not true? Thank you. Right? So, what is not? So let's go ahead and see. Score is greater than or equal to 80. That was true. So if I say not score greater than or equal to 80, I'm going to get false. It just simply flips it. This is way more useful than it seems, because it allows me to write an expression that looks like this. Done is equal to false, and then I can write an expression like this. If not done, right? And that looks like English, so that can be very easy to read, right? So you'll see me using the not done quite a bit when we do stuff. The reason I bring up these combined statements, which I plan on going into more depth in tomorrow, the ands and ors tomorrow, not really going to address them and how they work now, is because if you've got experience in other programming languages, then you may remember that if I wanted to check if a number's between two numbers, like x is 15, and I want to check if x is between, I want to essentially do the equivalent of this mathematical expression, right? X is between 10 and 50, right? In other programming languages, I'd have to go, hey, x is 10 is less than x, and x is less than 50. That's true, okay? And I haven't even explained what x is, but you kind of I haven't explained how and works, but you kind of intuit that that's correct. However, in Python, I love Python because we can cut out that middleman and just use the mathematical expression that makes sense. Right? So you can write compound statements like that in Python. Now we're going to go into more detail about that on Thursday because we have 20 minutes left and I want to get us back to our turtles now that we know more about the way our if-else statement works. Okay? So when we last left off with our turtles, we had a bit of a flickering problem, right? Which is that for step in range 500, right? And then if once we were greater than 100, right, we'd become red. And then if the step was greater than 250, we'd become blue. And then it would go red, blue, red, blue, red, blue because both conditions would activate and become true. Now, we can't just solve this with an if-else statement. Because we can't just simply change this to an else statement, comment out, replace this with an else. Because now the beginning will be blue rather than being orange. Why is that? Because we're saying, hey, if step is greater than 100, print out red. Otherwise, it's blue. And notice that we never change back from red. Right? Remember, this is now if statements are explicitly what are pretty much what I explicitly talk about when I refer to your computer being an evil genie who's doing exactly what you say, because you're gonna have to use logic muscles that you really haven't. Then unless you were addicted to puzzle books as a kid, or you loved logic puzzles as a kid, or you really had no issues with word problems, you wouldn't have really used these muscles too much. But these are the muscles that I'm going to be building over the next couple of weeks for you, right? The logic, the three-sort problem that you have, which is given three numbers, please sort them manually by hand, using the computer to do so, which is the last problem of this assignment. This newest assignment. That is one that is definitely meant for you to exercise those muscles. All right, going back to this. So how can we stop this from flickering? The else if won't really do it either here because it's orange in the beginning, then once it's greater than 100, it'll be blue. But with else ifs, the first thing, it's greedy. The first thing that works is the thing that gets it. Now sometimes the easiest way to do this is to just simply reverse what you're doing. Which is that, hey, if it's greater than 250, blue, else if it's greater than 100, be red. And notice how that logic is actually, it's actually internally consistent, right? If it's greater than 250, we're going to try, is the number greater than 250? Yes. Is it greater than 100? Yes. Or otherwise, is it greater than 100? So if it's greater than 250, we don't bother checking if it's greater than 100. Let's go ahead and comment this out. I'm not going to delete it because I want it to be there. I'm just going to comment this out, so if you want to come back to it later. We're going to go ahead and do something a bit easier with Bob, right? Let's recall how we make Bob draw a square. Okay? And basically drawing a square is repeating the same step 4 times in a row, which is, so for step in range 4, which means we do this 4 times in a row. Call it side because we're talking about sides here, right? For each side of a square, what do? We say, Bob, could you move forward? Some amount, 100. And then could you move forward? And then can you turn right? 90 degrees. And that will make Bob draw the square. No problem, right? Move forward 100, 90 degrees. Let's go ahead and actually make this a bit more interesting here. Because right now we've been using solid numbers for just about everything. We've been using literals. But really, I should be using variables. I could say length is equal to 200. And instead, I can put in length over here. And now we've made it something of 200. And now if all I have to do is just change the variable over here, and it will change the length over there. Why did I do that? Because future proofing, which is right now, and the future is now. So now let's go ahead and change this a bit. So that let's go ahead and draw each side of the triangle, each side of the square, a different color. So let's say if we're on the top side, side is 0. We're going to say bob.color is, let's go with red. And then if side is equal to 1, and we'll say bob.color is equal to blue or red, green. So remember, this side is going to increment. Side here we were moving 1 pixel at a time before. Now we're moving 1 side at a time. So the entire length of the side. And what we're saying over here is basically there's 4 sides. And the number for those sides are going to be 0, 1, 2, and 3 because we start counting at 0. 2. Bob.color blue. And side 3 is equal to bob.color pink. Right? Now, because there are 4 if statements and there's 4 sides, and each if statement has exactly 1 way to execute, we don't have to put else ifs or anything. It wouldn't hurt if we put else ifs. If we did if else if side is equal to 1, else if side is equal to 2, else color's pink, it wouldn't hurt. There's just more than 1 way to, they are semantically the same. There's more than 1 way to do things sometimes. But here we're saying if the side is the top, we're going to draw it red. Otherwise, if it's the right side, green, bottom side, blue, and then the left side, pink. So run it, and boom, 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 boom. It's pretty cool. But I'm a stereotypical hetero-cis male and I'm very intimidated by the color pink. So maybe I'll just try something else. So let's learn about how to make our own colors that will make me feel special. So with colors, you can provide a color code. Now we were talking about binary and hexadecimal the last time, and I'll go more into that number system because I'm realizing that's not something I really need to teach you right now. But let's go ahead and do. But what you can do is you can do the hash number and enter a number from 0 to 255 in hexadecimal, or 3 numbers from 0 to 255 in hexadecimal. FF00. And this doesn't really look that great, but just know that FF is as big as it gets because the digits are 0 through F alphabetically. And that produces a really bright, vibrant red because that's as much red as we can get. But honestly, that looks confusing because you don't know hexadecimal. So let's go to Turtle graphics again over here. And I just need to look this up because I always forget how to do the color. Color, red, So boom, boom. No, that's not what I want. Pen color. Okay. So that's right. That's what it is. So Turtle has what we call a color mode, which basically says that, hey, and there's two ways we can express color. We can express it as a normalized value as a decimal point from 0 to 1. By default, we enter in a 0 to 1 value. Or we can go from 0 to 255. So to switch it from 0 to 255, we do the following. Let's see. So I think we have to do turtle.color mode. Yeah. And then 255. And that will allow us to use values like this. So we can now express, rather than entering red, green, or blue, we can enter 3 numbers instead. So we can say, let's add maybe 100 red and 150 blue and 0 green. 3 numbers there. And there. It's not pink anymore. It's a much more manly purple. So, and what this is that basically that these values scale from red to, from black to white. So let's go ahead and see what that looks like visually. With the last bit of class over here. So I'm going to do a new for loop. For amount in range 0 to, let's go to 255. So we want to go up to, let's go up to but not include 255. So we're going to go, no, we want to go up to and include 255, so which is the maximum value, so we're going to go to 256. So what we're going to do is we're going to tell Bob, please move forward 3 pixels. Bob.forward 3 pixels. FD, by the way, I'm getting a bit tired of writing forward. You can just write FD to move forward. Wish I told you that earlier, right? And then we're just going to have him move forward 3 pixels. But before we do that, we're going to say, Bob, your color, I'm going to change that to amount 0, 0. So it's going to start out 0, and then so every group of 3 pixels, we're going to increase the redness of it just very slightly. So we can kind of visually see what's going on here. See how he's becoming more and more red as he moves, and we get this nice spectrum, right? So let's go ahead and call this, let's change this to redness, right? Because that's really what we're expressing here. And it's always good to have good variables name. Redness is equal to 0. So it starts out as 0, and then we increment and add more and more and more red. Now, interestingly enough, once we add more and more color, if we add enough red, green, and blue to this, we're actually going to get white. It's just the color model that we're using. Absence of any color is 0. All colors is white. So let's go ahead and add. So now if I wanted to do this, now I'd love to see how this looks like within combinations of blue, but I'm a bit limited here. So if I'm using just a single for loop like this, and this is going to get very scary for a bit, but I just want to do something really cool. That's okay. Then what I would have to do is basically, let's see, I would say, if I wanted to like make a two-dimensional swatch of stuff, I'd have to tell Bob, hey, Bob dot pen up, which means take up your pen, don't draw anymore. Because I want you to move you in such a way that I don't want you to draw. And now Bob dot go to, right? That go to function is really useful. I want you to move a bit down. I want you to move back to the center, right? 0, 0 to the center. But I want you to move slightly down, -1. And now do what you were doing again, but this time we're going to increment the blue a bit. And then once you're done with, and now that once you move back, right, Bob dot pen down, right? And now, right, what he'll do is that he gets to the end, and then he goes back, and it doesn't look like he moved down much, and doesn't look like he turned that much more blue. But he did, I guarantee it. But if I wanted this to go on like this, right? Notice if I wanted to like do a full swatch of color, I'd have to copy paste this and modify it 256 times. That would be terrible. What I can instead do, and what I'm going to leave you with, is that I can do a for loop inside a for loop, which is really cool. Blueness in range 256. And this is, again, so this is essential. And what I'm going to show you this is the scariest thing you're going to see in the first half of the semester. Guarantee it. This is as advanced as it gets. Once you master this, you can tell yourself, okay, I'm good to go. There's nothing that's going to stop me. So for blueness in here, go to bob.goto, and I don't expect you to understand this right now. The redness bit I kind of expected you to, but this part that I'm doing right here, no. Go to 0, blueness times -3. Let's try, yeah, that sounds like it'd be good. Blueness times -3, bob dot pen up over here. So pick up your pen, move to the center, and the coordinate equal to your blueness times -3. And then Bob dot put your pen down, Bob, because what I want you to do is now that you've moved to that appropriate line, I want you to draw a line of redness and blueness, of the set redness and blueness. And now if we run it, this will be the last thing you'll need to see. So now watch what will happen, assuming I didn't mess it up. This will take a while. In fact, let's go ahead and turn Bob's speed up. Bob.speed 8, right? Zero is actually instantaneous, so, or I thought it was. 10. Yeah, it's because we've got all these tiny little commands one at a time in there. That's why. Yeah, I gotta remember how it works that it does this. So I'm just gonna let it go while I look that up. Delay. Let's say. So let's say turn tracer. And then let's see ya. Let's get. Yep. Okay. I think I know how to do it. So turtle dot bob dot tracer 50. Turtle dot tracer 50. There we go. And so now you'll see that we'll get a spectrum. $5,000 and make it go down up. I hit the power button on my. All right, I'm gonna finish this up. You guys are dismissed. You can come here if you've got questions. But I'm gonna finish this up if you're interested. Bob, Tracer 5000. There we go. 2. Run. There we go. Let me go ahead and quit. The blue